Hello students, welcome back to Organic Chemistry. Let's see what is a prominent product for the given reaction. What many students do is that the moment they look at the reaction, they jump into predicting the structure of the products. But what I suggest you is that first analyze what is the reactant, analyze what are the reagents given, and then you can predict what will be the product formed. For example, in this case, it is unsaturated carboxylic acid, and the reagents added are iodine and a base. So this information will lead us to a reaction called as iodo-lactonization. That means it will tell you that the product formed will be a lactone. What are lactones? A cyclic ester. With this much information, you can easily predict the structure of the product. Students, in order to answer this particular question, you should be familiar with two concepts. First, what is iodo-lactonization and the stereoselectivity of the reaction? The second is what is the stereochemistry or the conformations of the bicyclic molecules like this, like in case of decalin, right? So let's discuss that one by one. First, what is iodo-lactonization? Whenever you have unsaturated carboxylic acid like this, say this is carboxylic acid, this is alpha, beta, gamma, and delta. So gamma delta unsaturated carboxylic acid, right? When it is treated with iodine, then the first step is attack of the iodine as an electrophile on the double bond because double bonds are electron rich, right? Therefore, the iodine attacks here and it's kind of forming iodonium ion. And this is planar. Now, the second step is the abstraction of the proton because you're using a base here. So what it's going to form? It's going to form a carboxylate ion, right? So here this iodine will be still in the plane. Now, when this oxygen, let's say it attacks here, so 1, 2, 3, 4, 5, it's going to form a 5-membered ring, right? So how do you write the structure of the product? So this is a cyclic ester. Therefore, you are going to call this as a lactone, right? So here we have oxygen attacking over here. And don't forget about the CH2 present here. That means this bond is breaking, right? So the CH2 is still attached to the iodine. So CH2 iodine. But let's see the stereoselectivity of the reaction. Whenever the oxygen attacks, it will be in the same plane where this carbon, right? So when it attacks here, this and this bond will be in the same plane. So how can you show that? So if say, let's assume this is above the plane. What about here? This also will be above the plane like this, right? So both of them will be above the plane like this. What about this particular group? It will be below the plane. So you can show it like the CH2 anyway. You can show it directly for the iodine. This will be below the plane. So this is the stereoselectivity of the reaction. So what you understand from here is that these two will be above the plane and this will be below the plane. So remember this first, okay? Because the same mechanism we have to apply for the given molecule. And you see, already there is one cyclic structure. We are going to form one more cyclic structure. That means we'll end up with a bicyclic structure similar to decalin. So this is decalin, right? So instead of this, we are going to have somewhat like this, a lactone. And remember, the decalin can exhibit cis-trans isomerism. How so? That is what I am going to explain now. Now, whenever we have a bicyclic molecules, right? So let me take example of decalin. Based on the hydrogens present here, right? So if both the hydrogens are above the plane, that means they are cis. For the cis molecule, the structure we write for the conformation is somewhat like this. The cis structures are quite stable, right? So that's why they can exhibit this kind of structure. So this is a cis molecule. Why so? Because look at this, hydrogen is above the plane. Here also hydrogen is above the plane. But what if the hydrogens are trans to each other, like one above, one below the plane? So in that case, the conformation we are going to write is somewhat like this. So above the plane, below the plane. So that means what? This is a cis structure and this is a trans structure. So you see there are two options which are cis and the other two are trans. Trans. Now we need to choose which is the right option. For that, first let's write down the lactonization happening for the given molecule. We'll write the molecule slightly different. See here, CH2, CH2, then we have COOH, so that it will help us to find out the stereochemistry of the product also. Now, what is the first step I taught you? That the attack of iodine, right? So here, this is where it is going to form the iodonium ion. So let's assume in the second step, the hydrogen will be abstracted and then the oxygen will attack. So the oxygen will attack here. So it has to attack from the same side, right? So for that, what I do is, look at this. This is quite interesting. I know it's a little bit difficult to understand, but if you just follow what I taught you, right, it will be easy. First, you write the structure like this, okay? Then we'll talk about the stereochemistry. So here the oxygen is being attacked. What did I tell you? That they will be in the same plane, either above or below. Okay, say let's assume this is below and this is below, right? What about the hydrogens? The hydrogen will be also in the same plane, right? So if they are on the same plane, it has to be cis. The product form has to be cis. Therefore, you can easily eliminate C and D here. So it has to be either A or B. Now let's see about the iodine. Iodine is always away from the oxygen attacked, right? So it has to be away from the oxygen attack, or you can say it's below the plane also, no problem. Let's analyze these two options then. Oxygen, iodine, they are on the same plane or it is above the plane. Oxygen, iodine, opposite, right? And also here it is below the plane. As I told you, it has to be away from each other. So where are they away from each other? In option B. Therefore, the right option here is B. It cannot be A. If you already know the concept of how to write the conformations, and if you already know what is iodo-lactonization, in one step, without writing any of these structures, you can find out the product. How so? In iodo-lactonization, you are getting the cyclic ester. So all of them are cyclic esters. And you know it has to be cis. Therefore, I chose either A and B. And oxygen iodine must be away from each other. Here it is away. Therefore, there is only one right option and that is B. As simple as it is. Right? And if you still don't understand how to write the conformational structures, you can always comment your questions or queries in the comment box. Thank you.